Hey everyone, welcome to today's new video. Today we will learn about sorting. I'll just write the topic for today, which is sorting. Um, Now what do we mean by sorting? So it's basically arranging the elements in a sorted order. When I say sorted order, it can be either increasing or decreasing. For example, let's take an example as 7, 11, 2, 5, 4, 9. This is our input array, and if we want to sort this array, the sorted array will look like 2, 4, 5, 7, 9 and 11. This is all sorted array in increasing order. I'll just start increasing. Same way, if we just reverse this array, it will be 11, 9, 7, 5, 4, 2. Yeah, this is also sorted, but this is in decreasing order. So sorting typically means rearranging the elements of the given input so that they are in either an increasing order or a decreasing order. It depends what we want to achieve. Now there are couple of algorithms which are there, which we will be talking about today. Uh, First is bubble sort, second is the insertion sort, and third is our selection sort. Alright, so let's start with bubble sort. Let's take the example which we have taken earlier, that is 7, 11, 2, 5, 4, 9. Now in bubble sort, how the bubble sort works is it takes two elements and compare them. So also just as a note, we will be discussing all the sorting algorithm to sort in increasing order. Right, now it takes two numbers and it compares if they are in correct order or not. So here we can see that 7 is less than 11, so they are in correct order. Okay, so it will check the next two numbers, 11 and 2. Now yeah, 11 is greater than 2, so it will swap the numbers. So the array will become 7, 2, 11, 5, 4, 9. It will then check, go to the next numbers, 11 and 5. Now you must be thinking that okay, 7 and 2 are still in incorrect order, but we'll get to that later. In the first iteration, let's say we are traversing the array for the first time, it will just keep on checking the pairs. Now it will check 11 and 5. Now again this is in incorrect order, so the next array will become 7, 2, 5, 11, 4, 9. Now as we can see that it will now go to 11 and 4, and the array will become, again this will are in incorrect order, 7, 2, 5, 4, 11, 9. Next it will compare these two elements, and these are again not in sorted order, so it will become 7, 2, 5, 4, 9, 11. Now we have reached the last index of the array, there are no more elements after that. So this is our final array after the first iteration. Okay, now again the loop will start, and it will start from here 7 and 2. It checks, okay, this is again in incorrect position, so it will swap. So it will become 2 7 5 4 9 11. Now it will check 7 and 5, and it will become 2 5 7 4 9 11. Next 7 and 4, again it will swap 2 5 4 7 9 11. So basically the crux of the this algorithm is it will keep on checking the adjacent elements and keep swapping if they're in incorrect order, and it will iterate the array until no swaps are needed, and finally it will return our the sorted array, which will be 2 4 5 7 9 and 11. Right, so now let's write the code for this algorithm. So we will take it as public static void bubble sort. We'll take the arrays nums, and it will be for int I equals to 0, I less than nums dot length I plus plus, boolean swap equals to false, for int j equals to 0. Oh, it will be I minus 1, j equals to 0, j less than nums dot length minus I minus 1, j plus plus. If my nums of j is greater than nums of j plus 1, it will give me int temp equals to nums of j equals to nums of j plus 1, and nums of j plus 1 equals to temp, and swap equal to true. So if it is not swapped, then we'll just break it, and we will just call this function passing in the nums, and it should work as expected. Now we'll just run this function, and it has printed the output array as 2 4 5 7 9 11. So this is how it works. Now if we discuss the time complexity of the solution, so we are using two loops. So I'll just write it here. Now here we can see there are two loops. One is going from 0 to n minus 1, and the other one is going to 0 to n minus I minus 1. Now why we have taken I minus 1? Because if you clearly see, like in our first iteration, our largest number is already put in the correct place, it's in the last, so we don't have to check for this one. And similarly in the second iteration, the second largest number is placed here, so we don't need to check here. So our first loop is going to n times into second loop is also going to n times, like theoretically, which becomes n square. So the time complexity of this algorithm will be O of n square. And space, since we are only using the constant spaces like this boolean and in temporary, so this is not taking any extra space, it is only taking constant extra space. So time space complexity is O of 1.